Hello, folks. Welcome to section 2.1, Modeling with Expressions. Here we're going to be, guess what? Talking about expressions. So let's begin. Let's start reading interpreting parts of an expression. So just to give you a little bit more information, not necessarily the math, but just information that's important and the terminology that's important. An expression is a mathematical phrase that contains operations, numbers, and or variables. So an expression can be something like 3 plus 7, It can be something like 3x plus 7, something like that, okay? So the terms of an expression, I'm going to use a different color to highlight this here. So the terms of an expression are the parts that are being added. Now, it also could be a minus, but if it's a minus, it means it's a negative term. But here you can see 3 is a term and 7 is a term. There's two separate terms here. And in the second one that I wrote, we have 3x and we have 7. That's two terms as well. The 3x, even though it's being multiplied together, it's still together and it still counts as one term. All right, a coefficient, let's use another color here. Let's use green. Okay, a coefficient is the numerical factor of a variable term. So this 3 right here is a coefficient of that term. Because it's a part of a variable, the coefficient is always the number, the numerical factor, of a variable term. It's the number that goes with that variable. Okay, so 3 is the coefficient there. None of the other numbers I wrote, the 7 here, 7 there, the 3 there, are coefficients because they're not attached to any variables. There are both numerical expressions and algebraic expressions. So a numerical expression is a simple expression containing only numbers. So for example, this right here is a numerical expression. It's just a number of terms, just regular numbers that are being added together. While an algebraic expression, let's use a darker blue. An algebraic expression contains at least one variable. So this expression here is algebraic because it at least has a variable like that x in it. So keep that in mind. The light blue was an algebraic expression and the darker blue was the did I say that backwards? The light blue is the numerical expression and the dark blue is the algebraic expression. And the difference between them is the algebraic one has a letter in it. It has the variable x. So that's just kind of a rundown of some of those terms, some of the definitions. So let's move forward. Identify the terms and the coefficients of the expression 8p plus 2q plus 7r. So the terms here, and I'm going to go back to my red. The terms here, well, we have 3 of them. We have 3 terms because we have 3 separate components that are being added together. So the terms are, 8p, 2q, and 7r. The coefficients, remember, are the numbers associated with the front of those terms. So the coefficients, we have an 8 is a coefficient for p, 2 is the coefficient for q, and 7 is the coefficient for r. So simply 8, 2, and 7 are coefficients here. We work our way down. Identify the terms and coefficients of the next expression. We have 18 minus 2x minus 4y. Now, since the expression involves subtraction rather than addition, rewrite the expression as the sum of the terms. So for example, we can rewrite this as 18 plus a negative 2x, because adding a negative is the same thing as simply that minus, and as well as plus negative 4y. So it's somewhat the same thing as just adding all 3 terms together, but I said earlier that if it is a minus sign, it's going to be considered a negative term. And you can see me doing that there, considering it a negative term, a negative 4y, a negative 2x. So the terms of the expression, the terms are 18, negative 2x, and negative 4y. It's very important we have those negatives associated with those terms. And the coefficients, going back to my coefficient color, the coefficients are only the the numbers associated with their variables. So -2 is a coefficient for x, and -4 is a coefficient for y. So it's just -2 and -4. 18 is not a coefficient because 18 does not have a variable with it. All right. Identify the terms and coefficients in the expression 2x plus 3y minus 4z plus 10. Now, since the expression involves both subtraction and addition, rewrite the expression as, again, the sum of the terms. So the expression positive 2x plus 3y minus 4z plus 10, well, we only really have that one negative term, so we're going to make it a plus a negative term. Just to kind of remember, all I'm doing this for is just to emphasize the fact that negative 4z, well, minus 4z is negative 4z. That's the only reason I'm doing this, is just to kind of emphasize that fact. So plus negative 4z. It's not something you would always have to do. It's just something that we're going to do now, just so that we become more familiar with the fact that it is negative. It's not just minus, but that is in fact a negative term. So the terms of the expression, we have 4 of them here. 2x is a term, 3y is a term, negative 4z is a term, and 10 is a term. The coefficients, remember, are just the numbers with those variables. So 2 is a coefficient because it goes with x, 3 is a coefficient that goes with y, and negative 4 is a coefficient that goes with z. 10, remember, is not a coefficient because it does not have a variable. All right, D, what are the terms of the expression? We got to read the thing first. All right, tickets to an amusement park are $60 for adults and $30 for children. If A is the number of adults and C is the number of children, then the cost for adults and children is 60A plus 30C. So what we're going to learn here is kind of how to write our expressions, especially when given a word problem. So when it has this expression here, it says $60 for adults and $30 for children, right? And it's converting it into this expression. Well, that's because it's saying 60, oops, that's not 6A, $60 times A, because it's $60 per adult. So if, for example, if I had one adult buy a ticket, it'd be $60. If I had two adults buy a ticket, it'd be 60 twice, 60 times 2, which would be $120. So we have to multiply those together, the reason why you see 60A. And that goes for the same reason for 30C. And we're adding them together because you would add up the total amount of tickets for the adults, you'd add up the total amount of money from the tickets for children and put them together, right? For example, if you go to the amusement park and your ticket's $15 and then your little brother's ticket is $12 because he's younger or whatever, then you just add the two numbers together to get a total. So that's essentially what they're doing there. So let's answer these questions though. What are the terms of the expression? The terms are 60A and 30C. What are the factors of 60A? Now this is a very interesting question. So factors is a funny term that means, let's write it down. Factors mean, I guess you can say, components multiplied together, in a sense, to make an outcome. So in this case, we have 60 times A that's being multiplied together. So the factors are 60 and A. Now there's a lot more to it than that, but that's what we're going to go with for that example. But just to give you a little bit more of a rundown on factors, just so you have a better understanding of factors. If I asked you for factors of 15, right, then I'm asking you for components that are multiplied together to make 15. So for example, factors of 15 would be 3 and 5, because 3 and 5 would be multiplied together to make 15. You could also say that 15 and 1 are factors as well, because 15 times 1 makes 15. So factors are essentially components that are being multiplied together to create a term. So in this case, this is essentially asking, what components are multiplied together to make 60a? And in that case, it's just 60 times a are being multiplied together to make the term 60a. It's kind of straightforward, sort of. So what are the factors of 30c? Well, similarly, it's the same thing. It's 30 and c are the factors that are being multiplied together to create that term 30c. What are the coefficients of the expression? So the coefficients, again, let's go back to my coefficient column, which is light green. Coefficients are the numbers that are being, that go with that variable. So 60 is the coefficient for A, and 30 is the coefficient for C. Now remember, it's just the numbers that go with the variable. It's not the whole term itself. You're not going to write, 60A and 30C because the A and the C are not the coefficients. The coefficients are just the numbers that go with that term. Okay, remember I wrote that earlier? I said it was just that 3. It's not the 3x, and we mentioned that with all these other ones, 8, 2, and 7. Right, not 8p, 2q, and 7r. It's just the numbers, okay? Interpret the meaning of the two terms of the expression. Well, we kind of mentioned that. I sort of mentioned that just a little bit at the beginning. I said, 60A is the cost for the adults, and 30C is the cost for children. Now, keep in mind, let's go back to red. When I say that 60A is cost for adults, it's 60 per adult, I should say. $60 per adult. Whereas, 30C is cost for children. But again, it's $30 per child. So one child ticket's $30, one adult ticket is $60. Obviously, every child that goes would pay $30, every adult that goes would pay $60. That's what the interpretation of our expression. Now let's look at a different one. The price of a case of juice is $15. Fred has a coupon for 20 cents off each bottle in the case. The expression to find the final cost of the case of juice is 15 minus 0.2b, wherein b is the number of bottles. Now, for a lot of us, reading this for the first time, it's really kind of tricky to understand, but because we just kind of read and we don't really really try to figure it out. But use your brain a little bit. Use your brain a little bit. We can figure this out, okay? So, one case of juice, boom, $15, okay? Now, we have 20 cents off for each bottle in the case. Now, just because the case is $15 doesn't mean it's 15 bottles. Let's keep that in mind. That case could have 20 bottles, could have 30 bottles, whatever. We just know the entire case is $15. But we do get 20 cents off of each bottle, however many bottles there are. We don't really know how many bottles there are. We just know that there's a certain amount, there's a big case of them. Now, because the coupon is taking off money, right, you have the $15 for the case itself, but then you're going to subtract 20 cents for every single bottle in that case, which is why you see the expression the way it is. You wouldn't add because then you would pay more money, which doesn't make sense. The case is $15, but you're getting a discount, so you're going to pay a little less than 15. You're going to pay 20 cents for every single bottle less. And why is it 0.2b? Well, 0.2 is equivalent to 0.20. Should really make that look better, which is a cent, 20 cents. So some of you might prefer, instead of writing 15 minus 0.2b, you might write 0.20b, because then it looks like 20 cents per bottle. But it is the exact same thing as what they wrote. But if it helps, I totally am down with it if you want to write it like this, just because it kind of makes it a little easier to understand. You can really see 20 cents a little bit better when you write it that way than when you write it the way they did. So I'm going to put it over here in the margin, 15 minus 0.20b. So $15, and then you're taking away 20 cents per bottle. Okay? So The terms of the expression. We have two terms of the expression. We have 15, and we have, remember, because it's a minus sign, that minus sign is going to go with that term. So technically we have a negative 0.2, or you can say 0.20b. Those are the two terms, 15 and negative 0.20b. All right, what are the factors of each term? So the factor for 15, well, I know I mentioned that example that factors of 15 are like 3 times 5, for example, but it's not asking for that much detail. It's only asking, is there anything in this problem that multiplies together to make 15? There's not. It's just that term 15 is its only factor for that first term. And we have, for the next term, we have two things, though. Negative 0.20 and b are the factors of the negative 0.20b term. Okay? Or you can say the second term, because that was the second term in the expression. Do both terms have coefficients? Explain. And the answer here is no, they don't. Because remember, coefficients only go with the term that has a variable. So no, 15 has no variable. So it's not a coefficient. The only coefficient we do have is the coefficient for our b, right? The number that goes with the variable, our b. So that coefficient is just negative 0.20. And by the way, every time I write 0.20, you're free to just write negative 0.2 instead. That's totally cool. I'm just writing out the 0 because it looks like 20 cents. So it helps me out. All right. What does the expression 15 minus 0.2b mean given the situation? So I've mentioned this at the beginning again. I always think this is a better thing to answer up front than at the end. But it basically says that the cost is $15, but the discount takes off money, and specifically it takes off 20 cents, or you can write that as 0.20 per bottle. So what they wrote in the book says, if Fred has a coupon, 20 cents is subtracted from the price of every bottle in the case. If Fred does not have a coupon, then the case costs $15. So that's what they wrote in the book. I wrote it my way. They're both basically the same thing, but there you go. All right, I'm going to reflect, and then I'm going to pause the video, end it there, because I'll save the rest for another video. So Sally identified the terms of the expression. 9a plus 4b minus 18 as 9a, 4b, and 18. Explain her error. So she did something wrong here. This is her expression, and then this was the answer she gave as the terms. She's done something wrong. Can you tell us what it is? Okay. Well, we know that 9a is a term. We can see that. We know that 4b is a term. However, what she's got wrong is her 18. Because it's a minus 18, that term should be negative 18. So we can say Sally didn't include the negative for negative 18. That was her issue. So number 2, what is the coefficient of b in the expression b plus 10? So what is the coefficient? So remember, that is the number that goes with that term here. Now, it's not 10. 10 is not the coefficient because 10 is not a part of that term. 10 is a completely separate term. So if you said 10, you were wrong. It's the number that goes with this term. But you're probably wondering, what number? I do not see a number. I just see b. Well, that's the trick. That number, it's invisible, but it is 1. b, that is the same as just 1b. But they never write 1. When it's just 1, they never actually write the 1. They always kind of leave it invisible because it's sort of redundant. We all know, everybody, who's learned this knows that if they just see B, it's implied to be 1B. So it's kind of a waste of time to always have to write 1. We're lazy when we're mathematicians, when we're older. So it's like, why write 1B when we can just write B instead? You know what I mean? So that's the reason there. So 1 is the coefficient for the exact same reason I just said. B is equal to 1B. The coefficient of B is 1. All right, guys, I'm going to end the video here. I will continue in here in the next video. So I'll see you guys later. All right, have a good one. Bye.